All right, so now we're going to, the biggest thing we got to remember before we go on and talk about the exponential function is to remind ourselves how we solved exponential equations, because that's going to be an important part of what we're doing this unit. So this will come up in a lot of what we do, so we got to make sure we remind ourselves on how to do it. So first things first is to recognize the difference between A and B. Just looking at it, what is the difference between A and B? Sorry? Close. This isn't the coefficient. It's the base. That's right. Your idea is right, though. Okay? So here, x is the base. How is that different from this? X is the exponent. Okay? One of these is an exponential function. One of them is not. Which one of these is an exponential function? A or B? B is the exponential function. The exponential function is the one that has your variable up in the exponent. What's A called? I'm sure the people watching this on video will be screaming at their computers because they know the answer, but no one in here knows the answer. What's this called? Oh, if only we spent 3 years studying this function. The quadratic, there we go. Remember that? X squared, right? This is just plain old quadratic. Okay? It's important that we know the difference, right? This is a quadratic, so there's a strategy to solve quadratics. This is an exponential function. There's a strategy for solving those. So the strategy for solving quadratics is to factor it or to just do the math. In this case, it's x squared equals 25. What's the opposite operation? Square root. So we take the square root of both sides and we get the square root of 25. And what's the square root of 25? Nope. It's not 5. Plus or minus 5. Sure, 5 is one of the correct answers, but it's a quadratic. And how many answers do we have to quadratics? 2. So it's plus or minus 5. Okay? These are not the questions we're studying in this unit, although we might need a little bit of review after how that went. This is the ones we're going to study. All right, does anyone remember how we go off and solve quadratics? Okay? Good. So in this case, we're going to leave 2 to the power of x, but the other one you're changing to what? Right. And then what? That's right. Very good. So what we didn't hear on the video is we are going to ignore the bases now. Because this is 2 to the power of x and this is 2 to the power of 3, they have the same base. The only way these can be equal is if their exponents are equal. So we actually sort of step outside the question and say, hey, this is the same base, this is the same base. The only way these can be equal is if their exponents are equal. So now I'm going to only look at the exponents. So I'm going to actually write this and look at the exponents. You'll notice I've put a therefore sign. I'm going to demand that that's part of our solution. Okay? Because we are not saying that this line here is equal to this line here. That's not true. Okay? But we've done a logical jump here. We're saying the only way that this can be equal is if we look at the exponents. So I'd like you to say, therefore, the exponents are true. And then now we have our answer. This method we had a name for last year. Does anyone remember it? Very good. Finding a common base. All right. Once we have a common base, then we know that if the bases are the same, we can just look at the exponents. The problem with exponential functions is trying to get at those exponents because we don't have an opposite operation for to the power of x. Okay, so we need other strategies, and this is what this whole unit's about. How do I get to those other strategies? So the one that we learned in grade 11 is finding a common base. That's going to be helpful for a lot of the questions, but in grade 11 we sheltered you and only gave you ones that you could find common bases. We know that that's not always true, and so this year we'll find out how we handle those. All right, let's use the same strategy in C. 3 to the power of 2x equals 9. What common base do you suggest we go to? 3. So we change 9 into 3 to the power of 2. We have a common base, so the only way these can be equal is if their exponents are equal. So what's my next line? What should I write down? Good. Therefore, 2x is equal to 2. Please don't forget that therefore symbol, because it makes me happy as a mathematician. Okay? Now, in this case, we don't have the answer right away, but we can do a quick little algebra and divide both sides by 2. And we get x equals 1. Okay, so let's keep going and use this strategy of finding common bases. So in B and C, it was pretty easy to find a common base. In B, we saw 2 as a common base, and C, we saw 3 as a common base. Do you think 4 would be a good common base for D? Yeah? So can I do this? Don't even do it. Is that true? No, that's the most common mistake we see, because is 4 squared 8? 4 squared is 16, right? So that doesn't work. So instead, we're not just going to change one common base, we're going to change them both. What common base do you recommend? 2. So we're going to change 4. 4 is 2 to the power of 2. And then it's raised to a power of x, and we'll deal with that in a moment. What about 8? 8 is 2 to the power of 3. All right, so now we have a common base. But before we go any further, let's deal with this. I have 2 squared being raised to an exponent. What operation do you do when you have one base being raised to 2 exponents? What do you do to those 2 exponents? You multiply them. Add them is when you have 2 bases, right, with the same base, and then you add those exponents. Here we've got 1 base, but 2 exponents, we multiply them. So that's a simple multiplication. 2x times x, or sorry, 2 times x is just 2x. So it's 2x equals 2 to the power of 3. Do we have a common base? What's my next line? Therefore, 2x equals 3. A little bit of math tells me that x equals 3 over 2. We need this strategy because it's not an obvious answer. If you look at the question, you might have been able to say there in B that there was an obvious answer, right? In B, you could have said maybe there's an obvious answer. It says 2 to the power of something is 8. Well, it's not 2, it's not 4, 2 to the power of 3. So you probably could have said that's an obvious answer. You maybe even could have done some fiddling and figured out what the x value is in C. But in D, that's not an obvious answer. 4 to the power of what gets you 8? Well, that's a challenge. So we need this strategy. And the strategy that we learned last year is finding a common base. All right, what about E? Do we already have common bases? Yep. So we can go straight to comparing their exponents. So the next line is, therefore, 2x plus 5 equals x plus 4. I don't care whether the exponent is just a plain old x, or a 2 to the power of x, or a big long expression like this. The strategy is still the same, so we compare the exponents. Now a little bit of algebra, bring the x's to one side. That's just an x, a minus over here, so it's minus 1. Okay? So doesn't matter what those exponents are, we can still handle them. So in F, we're going to try and do the same thing. Any ideas for a common base in F? 4? No, it's okay. 4 is a possibility because I see 4 squared is 16, but we can't get 8 as 4. So let's try something else. What about 8? No, 8 squared would be way too big, right? 8 squared is 16. Sorry? 2. Let's try 2. 8 is 2 to the power of 3. So I'm just going to change that, and I'll deal with the exponent in a moment. And 16 is 2 to the power of 4. And I'll deal with the exponent in a second. So just like in our question back here, we have one base, but we had 2 exponents, so we multiplied those exponents. Same idea here. We've got one base, but 2 exponents, so we're going to multiply them. The only catch is there's a little mini rainbow happening here, right? It's 3 times this whole thing, so we got to do a little mini rainbow. So that becomes 2 to the power of 3x plus 9. Same little mini rainbow over here. Equals 2 to the power of 8x plus 4. Do I have common bases? Yep. So therefore, I can ignore the bases and only look at the exponents. Bring your x's to one side. It doesn't matter which side. I'll bring it over here. That's -5. That becomes -5. Divide both sides by -5, and we get +1. You could go off and verify this if you really wanted to. We said that we solved for x equals 1. So let's actually check the left side. 8 to the power of 1 plus 3. So we just substitute the x equals 1. So that's 8 to the power of 4. Can someone punch that in? Tell me what 8 to the power of 4 is. 4,096 off the top of my head. Just for you watching at home, nobody answered that. I did that all in my head. Okay. On the right-hand side, we had 16 to the 2x, so it's 2 times 1 plus 1. That's 16 to the power of 3. And without even asking anyone, I knew the answer was 4,096 because I know my 16 times tables.